Maxima and minima of trigonometric functions. So I'm discussing short tricks for maxima and minima for the functions containing trigonometric terms. Formulas have been found using first derivative and second derivative test with a long procedure, and the result we can use for the questions in competitive exam. If f of x is equals to a sin x plus minus b cos x, then maximum value is square root of a square plus b square, and minimum value is negative of the same, means negative outside, and square root of a square plus b square. For example, suppose we need to find maximum value of f of x is equals to 2 sin x plus cos x. So here a is 2, b is 1, maximum value is given by directly we can use the formula 2 square plus 1 square under the root, that is root 5. Similarly, we have another formulas. Suppose fx is equals to a secant x plus b cosecant x, then only minimum value is known to us, a to the power 2 by 3 plus b to the power 2 by 3 whole to the power 3 by 2. If f of x is equals to a square secant square x plus b square cosecant square x, then minimum value is only known to us, that is a plus b whole square. Three similar formulas we have here. If f of x is equals to a tan square plus b cot square, minimum value is given by twice of square root of ab. The condition is a and b should be positive quantities here. A and b are positive numbers. Similarly, like tan and cot are reciprocal functions, similarly we have fx is equals to a cos square plus b secant square x, reciprocal function. Another one is a sin square plus b cosecant square, reciprocal functions. The minimum value is given by twice of square root of ab, and the condition is same, a and b are positive. If f of x is equals to x plus 1 by x, then minimum value is 2. We can use this formula directly also. So questions based on the same. If f of x is equals to f of theta, here is a secant square plus b cosecant square, then minimum value of f of theta is option a plus b, option b twice of square root of ab, option c a plus b plus twice of square root of ab, option d a plus b whole square. So function here is a secant square plus b cosecant square. We have results with this a tan square plus b cot square, or a sin square plus b cosecant square, or a cos square plus b secant square. The minimum value is given by twice of square root of ab, means we should have the reciprocal function, and here we have, in the question we have secant square and cosecant square. So either change one of them or we can change both. Like secant square is convertible into tan and cosecant square is convertible into cot using identities. So this will become a plus b plus a tan square plus b cot square, and a tan square plus b cot square's minimum value is twice of under root of ab. So minimum value of f of theta is a plus b plus twice of square root of ab. Similar result we have studied previously, like f of theta is a square secant square plus b square cosecant square, minimum value was a plus b whole square. So whatever formula we apply, we'll be getting the same answer. Like I am doing a question based on the two formulas. What is the minimum value of 8 secant square plus 2 cosecant square? If I am using the above formula, which we have just proved, from above result, a here is 8, b here is 2. The result will be a plus b plus twice of square root of ab, that will be 18. Same question I am doing with this result. When you consider a square, so 8 can be written as 2 root 2 whole square, 2 can be written as root 2 square. Now a is 2 root 2 and b is root 2, and minimum value is a plus b whole square. We will be getting the same answer. So it doesn't matter which formula we use. Next is, what is the minimum value of f of x is equals to sin square x plus 3 sin x plus 1 upon sin x. So options are given, and this function can be made of the kind x plus 1 by x. If we divide by sin x, we get sin x plus 1 upon sin x plus 3. So this we have studied. Fx is equals to x plus 1 by x, minimum value is 2. So minimum, whatever x is. So here x is sin x, minimum value of sin x plus 1 upon sin x is 2. So minimum value of the function is 2 plus 3, 5. 5 is the answer. Next is, we need to find the maximum value of 16 to the power sin theta into 8 to the power cos theta. So after simplifying them in 2 to the power something, so this will become 2 to the power 4 sin plus 3 cos, right? So we need to think about 4 sin plus 3 cos theta by a sin x plus b cos x method. A sin x plus b cos x we have studied, maximum value is twice of square root of a square plus b square. So here maximum value of 4 sin theta plus 3 cos theta is 4 square plus 3 square under the root, that is 5. So maximum value of f of theta will be 2 to the power 5, that is 32. Minimum value of 32 cos square theta plus 2 tan square theta. F of theta here is 32 cos square plus 2 tan square. We need to convert them into reciprocal functions. So replacing tan square by secant square minus 1, cos square and secant square will make the formula for minimum value twice of square root of AB, that is twice of square root of 64, 16. So minimum value of the function will be 16 minus 2, because minus 2 is there, 14 is the answer. Next is, what is the minimum value of 6 minus 4 sin theta in the first quadrant, theta lying in the first quadrant. So 6 minus 4 sin theta, for function to be minimum, the term which is subtracting this should be maximum. So for f of theta to be minimum, 4 sin theta should be maximum, and maximum value of sine in the first quadrant is 1. So maximum value of 4 sin theta will be 4. So minimum value of the function will be 6 minus 4, 2.